talk about how to extract data from the inbuilt modules of Python. Last time I told you to from that you should download that Titanic dataset from internet sources like kaggle.com, but you could have also loaded it from Python inbuilt libraries. So Python's inbuilt modules also allows us to practice machine learning, right? So extracting data, we will look at how to do that, and what we will extract, something known as diabetes dataset. Today we will understand that dataset. We will do cleaning. Actually, in inbuilt Python Scikit learn libraries, the most of the datasets are already cleaned, so we do not need to do much of the cleaning. And I will show you how to apply an algorithm today. So by the end of this video, you will be able to load the database from the inbuilt Python modules, know various important websites essential for machine learning, and manipulate the loaded data, and know how to apply an ML algorithm on it. So first we import the required libraries, and then from sklearn import datasets. This datasets is the module which are having a lot of stuff. It also has a Titanic dataset. So our object we create as dia equals to dataset dot load diabetes. As soon as you write load, there will be a drop down menu will appear, and you can select diabetes from that. You could have also selected Titanic, right, or whichever data set you want to work on. And this our data set is in the form of numpy array. There are more, and there will be description also written. So x dot diabetes dot data, we store it in x. So this is our data, and target is the target. So x and y values, basically data is the x and y values, the features x1 x2 x3, all the features we are having. And these are the these are single 1D array. You can see this, it is not 2D, it's a comma separated 1D array is the target, the predictions basically which we need to do. So pd.dataframe consists of these things. So dia of feature names means what are the names of our columns, what are the names of the features of X. So we can get that using dia of dot feature names. So if we do df dot columns equals to dia dot feature names, or all the columns will be named like this. So let us just look at our database now. What is this age? You can see this. So uh, you can see gender, BMI, blood pressure, and these are the serum levels basically of these are required to predict whether you are having diabetes or not. So a machine learning model can also predict whether you are having diabetes or not. So see, now you see how can age and gender be negative. You are seeing a negative values. BMI also negative, blood pressure also you are seeing as negative. Many things. How can age be negative and how can age be 0 point something? So what is this basically? This is, I told you, these datas are already cleaned and well arranged. So if you remember the Gaussian distribution, right, from a little bit of negative to little bit of positive, it has the range. So what I think is the data sets are already cleaned and they are compressed, and the datas are already normalized, maybe normalized. You can see everything is between -1 to 1, or maybe Gaussian distribution curve is applied on this, so everything gets within particular range, right? You cannot work with something like age being 70 and BMI, some blood pressure being something very less, or age being something more. You need to have data which are at par with each other. So to convert those, I also talked about feature scaling and all. You can go through those videos, you will understand this easily. So df.describe, this most of the times we will use this is very important. So what it returns count 442. There are 442 rows. Mean, standard deviation, minimum value. This is 25th percentile score, 50th percentile, 75th percentile, and this is the max value. What is percentile? Basically 25th percent. If every age is arranged in the ascending order, then the 25th percent, first 25th percent is this cutoff of the first 25% is this. Dia of DS description basically. So if you are working on a project and you don't know what is the project is about, so on the file handle or on the project handle you will first write this DESCR and read what is written basically. You can see here everything is written, as well as the response of the internet, variable baselines, age, sex, body mass index, average blood pressure, and 6 blood serum level measurements were obtained from each of diabetes patient, as well as response of interest, equality to measurement of the disease progress. So it is about the project which happened. It is written in detail. So today now we will apply this linear regression. So what is this linear regression? I have not explained it, so you just now assume it to be a black box, right? It is some AI algorithm which we are going to apply. So we are now going to learn that how to apply it. Just we don't know anything how to apply this. Our AI model is ready to apply, right? So how to apply? From SQL and import model selection, or we can also do from sklearn dot model selection import train test split. You can also do it that way. Extend xtest, y test, these are the variable. Training data set, testing data set of x and y values. I already told about what is this training and testing. Some amount we need to keep for testing, also some amount will be training. So by default this training data set is 75%. So out of 442, 75% will come approximately to be 331, and you can see X train and X test are basically 2D arrays now. So from sklearn.linear model import linear regression, object equals to linear regression, object.fit X train Y train. So from sklearn.linear model you need to know this. To import linear regression, suppose this is the name of the algorithm. There will be many other algorithms, you can select anyone. As it is, you are now using this as just a black box. So object dot linear regression, and you are fitting your model here. Then object dot intercept. These are basically the output, which in next video we will understand in detail what is the output. So this is the y predicted values of the testing data set, which is the y predicted values, and y test is the actual values. So you can understand this how by plotting this curve you can easily see what curve I plotted. It is the between y test and y predict. So if it is approximately a straight line, right, you cannot expect things to be so much simple in real life. So along y equals to x, more or less the data is going. You can say it this way, you can assume it that way. So our y prediction is approximately equal to the test. So in this video and the previous video, whatever I told you, you need to do thorough practice. So you should visit these websites. Mukaro.com, you can download databases from here. Kaggle.com, I told you, UCI machine learning and Google Colab is very important, which I will tell you how to use this in detail, and you can definitely go and explore these now. And download your work is now that you must download Iris dataset and Titanic dataset from Kaggle.com and import them and explore. Like I told you about the diabetic dataset and Titanic dataset, you must do it. The data cleaning you should do by yourself also once. So your work is to load Boston dataset from inbuilt Python library and modify it and apply linear regression algorithm in a similar manner as we did today. This will be your work to have a thorough understanding of this. Unless you work it out, unless you code it out, just seeing the video will not make it, right? So yeah, that's all from this video. Thanks a lot.